All right, let's learn about the rational zeros theorem. For example, let's find all the zeros of this function f, given we know that it has at least one rational zero. And we're going to use the rational zeros theorem to help us out here. The rational zeros theorem gives us all the possible candidates for rational zeros of a polynomial. It tells us that the possible rational zeros of f are of the form p divided by q, which is equal to factors of the constant term of the polynomial, which in this case is -2, divided by factors of the leading coefficient, which in this case is 3. All right, so what are the factors of -2? They're plus or minus 1 or plus or minus 2. And then divided by the factors of 3, which are plus or minus 1 or plus or minus 3. Now doing all possible divisions here, we have plus or minus 1 divided by plus or minus 1, which is plus or minus 1. And then plus or minus 2 divided by plus or minus 1, which will give us plus or minus 2. And then plus or minus 1 divided by plus or minus 3 will give us plus or minus a third. And finally, plus or minus 2 over plus or minus 3 gives us plus or minus 2/3. So we have 8 possible candidates for rational zeros of this polynomial. And we know at least one of these will have to work because we're told we have at least one rational zero. So what we need to do is start trying these possibilities. So let's begin with 1. We'll know 1 is a zero of f if we evaluate f at 1 and we get 0. So what do we get? We have 3 times 1 cubed, and then minus 2 times 1 squared, minus 7 times 1, minus 2, which is equal to, this is 3 minus 2, which is 1, and 1 minus 7 is -6. -6 minus 2 is -8. So no, this is not a zero. All right, what about -1? Let's plug -1 in and see what we get. This is 3 times -1 cubed minus 2 times -1 squared minus 7 times -1 minus 2. So we have -3 and then minus 2, which is -5. And then plus 7 is +2, and then minus 2, so yeah, this is 0. So -1 is a zero of f, which means that x minus a -1 or x plus 1 is a factor of f. Therefore, by the factor theorem, we can write f of x as x plus 1 times some polynomial q of x. And we can find q of x by dividing f by this. So let's do that. So x plus 1 into 3x cubed minus 2x squared minus 7x minus 2. All right, so x goes into 3x cubed, 3x squared times, and 3x squared times x is 3x cubed. And then we have plus 3x squared. And now subtracting, we have minus 5x squared We still have this negative 7x minus 2. And now x will go into negative 5x squared, negative 5x times. And negative 5x times x is negative 5x squared. And negative 5x times 1 is negative 5x. Subtracting, we get negative 2x, and then we still have the minus 2. And x goes into negative 2x, negative 2 times. And negative 2 times x is negative 2x. And then minus 2 times 1 is negative 2. And when we subtract, we get 0, which shouldn't surprise you because this is a factor of f. So here is q of x. So let's write that down here. We have f of x then is equal to x plus 1 times q of x, which is 3x squared minus 5x minus 2. Now to find the remaining zeros of f, we need to factor q of x. And q of x will factor into 3x plus 1 times x minus 2. So f of x will equal 0 when this is 0, which means x is equal to negative 1. Or when this is 0, which means x is equal to negative 1/3. Or when this is 0, which means x is equal to 2. Therefore, our zeros of f are negative 1, negative 1/3, and 2, which would be our answer. Now notice the last two zeros are rational. They better be in our list of candidates, are they? Let's look. Here's negative 1/3, and here's 2, so they are. And this is how we use the rational zeros theorem. Thank you, and we'll see you next time.